Hello, I'm Mark Warner, founder of Warner Advisors, a consulting firm formed to help biotechnology clients take their process from concept to commercial operation. Welcome to the series Understanding Advanced Biotechnology Commercialization. This is part 4, Startup. Let's begin with a refresher. Below is the project execution timeline we've been discussing throughout the series. And you'll see on the far right, we're discussing the startup stage, which is the commissioning and the startup of the facility. There are, however, two other concepts I would like to bring in. The first is the concept of mechanical completion. This is a point in time when the construction is complete and commissioning can begin. The second is release to operations. This is the point when the startup is complete and the facility is reliable enough to be handed to the operations staff to go into long-term production. So what is included in the startup phase? Testing and operating the facility following construction. It's a structured process that's led by the engineering and technical team. The startup crew will check out the equipment and make sure it was built as it was engineered. They'll test basic functionality with water or other inert materials and ensure the systems are able to be operated individually. Then they'll run them in smaller groups and ultimately they'll run the complete facility together. A new technology startup is a very demanding time for a new company. It's going to take a lot of staff and a lot of resources, and this is something that a startup needs to plan for. A few things to consider as we start the startup operation. First, construction activities are much faster and more efficient when all the utilities, the power, the steam, and other things are turned off to the entire site. This is generally what happens during most of the phases of construction. As you begin initial operations and startup, as you bring power and steam on, any remaining construction activities will actually be much less efficient due to the procedures they're going to need to do with steam and power and other things there. It doesn't mean that you shouldn't start up the portions of the facility while finishing construction. You just need to understand if you do that, the remaining construction will be much less efficient. Startup is a marathon, not a sprint. It's going to take months, not weeks, to start up a complex new facility. This is something that both the company and the startup team need to be prepared for. It will be a while until you're ready to produce product, and the first material is likely not going to be saleable. This is something that also should be on the radar. The other item I like to discuss is what is production going to look like over time. If you look at the chart below, the first green line is what I call the analyst view of how they often view production over time. When a company gives a startup time for a new facility, you often see forecasts by the analysts of revenue and other things showing that the facility will be near capacity within a month or two of production, which is seldom reality. The red line is more like most company projections and really reflects more of what reality will look like over time. As the plant is started up slowly, you'll see that it increases its rate of increase fairly rapidly, probably up to the 40, 50, 60% range, where at that point, often things start to tail off and the amount you're able to increase over time starts to diminish until you eventually are able to reach your capacity production rate over time. This can often take 6 to 12, even 18 months on some technologies to reach the nameplate capacity of the facility, at least for extended periods of operation. Finally, the blue line represents more of what the day-to-day, week-to-week reality of a startup looks like. You're going to start up initially, run for some short portion of time, and probably find a handful of items that need to be addressed, repaired, modified to get the facility fully operational. You'll shut down, make those changes, and start up a second time. You should come up to a much higher level of production, run for a little longer, but it's also likely you're going to have to make some changes, hopefully less and not as complicated as the first level, shut down, make those changes, and then hopefully start up to a much higher level and a longer sustained level of operation. This is really the reality of what a commercial startup of a new technology looks like. While the red line fairly represents what an average would look like, the blue line represents more what the reality of day-to-day, week-to-week operation will look like. Let's talk about the dimethyl glop facility as an example. Let's say we've done some of our initial commissioning and we're ready to start a fermenter. What is that really going to look like? First, the utility systems we're going to need. We're going to need power to run motors and the agitators. We're going to need cooling water to cool the equipment. We're going to need chilled water for the fermenters, assuming they run on a chilled water source. We're going to need steam boilers to be able to provide blocks and bleeds, and also to be able to do the sterilization of the equipment. Compressed air to drive the fermenters. And within the fermentation system itself, we will need the pre-seed system, we will need the seed system, we're going to need the main fermenters operational, the ability to run the sugar sterilizers, we're going to need nutrient preparation and feed systems, we're going to need sterile filtration for any components going into the fermentation, we're going to need the clean in place system operational, and we're going to need the off-gas scrubbing system. For a process like the dimethyl glot process we've been talking about that would probably cost about $30 million to build at commercial scale, there are going to be about 30 of these subsystems that are going to need to be proven out for the facility. Each one of these has to be checked for completion, commissioned, flushed, and then operated on an individual basis. Once they're proven individually, they'll be run in groups and eventually together as a whole plan. It's the interdependence of the subsystem and running everything in unison that's the goal, but it's also the most complex portion that will take some time to achieve. So let's review what's involved in mechanical completion. What is mechanical completion? It's the point in the construction when the plant is functionally complete. The main process equipment is installed with piping and utilities connected. The engineering teams verified the construction against the drawings to ensure the facility was built as designed. Home renovation analogy is when you come into your new kitchen, the construction's complete, but you've not turned on the utilities or tried to run everything. You haven't turned on the faucet to see if water flows. You haven't turned on the stove to see if there's gas to it and the burner's light. And you haven't tried to operate your oven to see if there's power to it and it will heat up. As you will remember, mechanical completion is a milestone point in time, so we'll move into the next phase, which is commissioning. What is commissioning? It's the initial testing of the equipment to test out basic functionality before you operate it. You'll flush equipment with water to make sure there's nothing left in the pipelines, pumps, or other equipment. You'll pressure test all of the piping and tanks with water to make sure they'll hold their proper pressure rating. You'll stroke the valves to make sure they operate correctly, opening, closing, and controlling the way the control system shows them to be operating. You'll test pumps to make sure they work and they can be controlled from the control system. And you'll run systems on water to set initial calibration and flow of the systems. This phase is to check out equipment to make sure it's ready to operate, but you don't actually try and run the equipment at this point. So once you've done your initial checkouts, then you're ready to move into initial operations. This is where you use water and other inert materials to make sure everything runs as expected. The pumps will pump, the mixers mix, and that the equipment appears to be running safely. The engineering team leads this effort, but it's important that the operations staff work with them to gain on-the-job training. Generally, when new operators or technicians are hired, they go through a fair amount of classroom type training, but they need to become familiar with the plant. Working side by side with the engineering team is usually the best way to do that. Once you've proven all these systems on a standalone basis, you need to run them in combination with one another. All the systems need to be tested in these initial operations before any live materials are used. And by live materials, I mean real feedstocks like sugar, acids, bases, and other materials you'll bring into the facility. So once you've completed the initial test out and operation, you're ready to move into the startup phase. So what is startup? It's when you start using real feedstocks with the intent of making a product. It's a watershed moment for a new plant. It starts a requirement for around-the-clock shifts, including startup team coverage. You're going to encounter problems at varying levels of complexity, and they're going to emerge almost immediately. Try and limp along with as many of the workarounds as you're going to develop as is practical. Identify problems, order parts to repair the equipment. Shut down on a planned basis and make the necessary changes. The goal is to run longer and more reliably each time you restart the facility. But please realize you only learn from running the plant. Fight the urge, especially in the early stages, to shut down over non-critical items. Run by limping along with workarounds to identify as many issues as you can, order the parts, make sure you have them on site, then have a planned shutdown to deal with a handful of them at once. This is going to be your most efficient way to work through the inevitable issues you're going to get with the new facility startup. As I've had the opportunity to lead multiple large-scale new technology startups, I would like to offer a few lessons from the School of Hard Knocks. The first is plan for the storage and reprocessing of off-spec material. It's inevitable that you're going to generate this material during startup, so be ready for it. It's not a question of whether your startup crew is going to get burned out, but at what point they'll get burned out. You need to make sure you have reserve staff identified and a plan to rotate them out if necessary. Planning is necessary, but startups don't happen in a conference room. Once the plant is operable, you can really only learn by optimizing and running it. Your focus needs to be on getting the plant running, keeping it running, and making incremental changes. Also, running in a manner different than the facility was designed is a huge mistake. I see this happen a lot during startups where many of the startup team may be familiar with, say, running the pilot plant that is often a batch system where the commercial system is a continuous system, and they'll want to run the operation in a manner they're used to, even though it wasn't designed for that, and I find that to be a big mistake. As I like to tell people, when all else fails, run the plant like it's designed. It's a big mistake to try and run it a different way. The second thing I've learned is when you're ready to operate the plant, drive it like you stole it. What I mean by this is, while I'm not proposing trying to run at capacity before you're ready, it's also a mistake to try and run at very low levels of production. I'll often see startup teams try and run 10-20% of production, assuming it's safer or in some way going to be easier to do. And what I've found is most facilities don't turn down that well. Running less than, say, 40 to 50% of capacity is often very difficult for a technology. So when you're ready to run, you need to be prepared to run at least probably in the 50 to 70% of capacity rate for most technologies. That's where they run better, and you need to continue to push the production up from there. Release to operations. This is the point that every startup crew looks forward to because the release to operations is the point when the startup crew is going to get to go home. So what is involved in releasing the new facility to operations? This generally occurs on a system-by-system basis. When each system is proven to be able to operate as designed and the operators have been trained, it'll be handed over to operations. Good example is utilities are some of the initial things where the boilers, the chillers, the cooling towers, those would be proven out, tested, and once operable, handed over to the operations crew to run on a daily basis, while the engineering crew may still be doing the startup and initial operation of things like fermentation and some of the downstream equipment. Along with this comes the production planning and troubleshooting responsibility. As operations takes over responsibility for sections of the plant, it will be theirs to plan the raw materials, outbound shipments, and troubleshooting of issues. And at this point, it's when the focus changes from proving out the equipment to trying to keep it running reliably and in a repeatable production mode. At this point, it's important that changes need to occur less often and go through a management of change process. Once you get into regular operations, it's a very costly time of operation. You're running more raw materials, and you're frankly expected to make a product within a certain specification. You need to be very careful that once you get the plant lined out and you're making on-spec material, you want to make sure there's a high-level review and you have all the parties involved before you talk about changing the process, because it can definitely have negative impacts. I want to thank you for watching this series, Understanding Advanced Biotechnology. If I can answer any questions, please don't hesitate to contact me at mark@warneradvisorsllc.com, or for additional information, you can visit www.warneradvisorsllc.com.